Hi, I would like to go through the deployment process of the database and also show some circle commands to get some understanding about the data and also find some extreme values and also determine the condition to clean the data from the dataset for further analysis. So in this screen, it's a vSphere client management user interface. You can see here, I have lots of virtual machine on my server. So for this course, I only use Ubuntu Linux system with my Circle database and also RStudio server to do this data analysis work. So we can first check the summary for this machine. All of the settings are virtual, but we can modify it when it is necessary. So for this machine, I give it a big memory and lots of CPUs to enhance the query performance and also some computation. And for the storage, I didn't give too much because our database is only about 10 gigabytes. So let's go to the Workbench user interface. In this interface, I have connected to my server. We can check the settings here, and we can also add settings. I use SSH. It's a more secure method, and it can save lots of time to set up the remote login for the MySQL file. So let's go to our database. So here we can see that our database name is MBZDB, and all the tables are listed here. Actually, when I first deployed this database, there are lots of empty tables. So actually, I have deleted them by the commands. There are lots of tables without any records. So for the data cleaning process, firstly, I delete all this zero information data. So also, as the database is very big, and the machine, even it's a server, it cannot do very well for such amount of data. So I just simply delete some records which we will not interested in. After that, we begin our query. Of course, we need to build the index before the query. And for these queries, I'll go that one by one to show you the properties of the tables, the quantity of the data, and also how can we handle the missing and some issues. So first we go through the most kernel one. The most kernel entity for this database is release, which describe the release of album. So actually, I think this database is just extract the data from all the publications around the world. So we first go to this command and get some basic common sense about the release table. Okay, here we are. To make sure the response time, my circle will automatically set the limitation about this kind of query. Actually, it's for all query. So we only show the 1000 records here, but we will check how many records in this table later. So here is a table for the release. We can see ID, which is the primary key for this table. the GID is a surrogate key in this database, and actually we don't know how to use it, but using this key is a good way to trace something in this specific database. Also the name, we can see there are some exchange characters here, which might be caused the encoding issues, because the language around the world has lots of different coding. So when deploying this database, maybe there are some issues they didn't the official guide didn't consider very much. The artist credit is a foreign key connected to the artist table. We'll talk about it later. And the group is the publication group. There are also several other data. So we first go to check how many records in this table first. Here we are. There are about 1.5 million records. So in this amount of data, it's not easy to handle by some kind of tools like R or Python on a laptop. Even if you want to use R or Python on a server, it's better to run it on a parallel computation environment, and also a big memory to make sure the stack overflow will not be happen. So besides understanding the total amount, we also need to know what kind of columns do they have and what kind of constraints when they establish the database first, which is a good way to understand what kind of possibly things will happen in our data set. So here we can see most of the column cannot be null, but several of them can be. So let's check these columns to check if there is any missing and how much they have missed. So here we are. So actually, because we are focusing on the Grammy and AMA award, which only focus on the English language, or I say mostly focused on the English language. So for the language column, we will have a look here, but actually I don't think we need to dig too much for this column, because we can just choose the English songs, English music with English title. So it's okay if there is some missing here. Also, you can see that there are lots of missing in the states, packaging, and also script. So if you would like to have a look about the comments I write down here, the states is attribute that is describing the how official, what kind of publication it is, which is not very important for our analysis. So this column can be dropped when we extract the data from this database. And the second is the packaging. The packaging column is describing what kind of package about this album is using. Like maybe they use a plastic box, maybe they use a paper box. They have some indicator here to show this information. So we don't think it's necessary for us to understanding how people think and how academics think about an album. So we can also ignore it. A language we have said before, as for the script, is describing what kind of encoding method for this release. It's just something to describe different languages, and actually there are lots of language around the world, so there are lots of script around the world. So we are not very interested in this column either. So secondly, I would like to check the time, because maybe there are some mistaken records or even some wrong records, and check the time is an easy and efficient way to detect these unreasonable records. So let's run it. It takes a little bit long time. So here, as we have deleted all the records in the release table, which date is a little bit earlier, because we will just focus on the on the time after 2010s. So we only save this data here, and today's time is today's date is 2016. So these two records must be some wrong, and we will delete it after we analyze the database first. So most of the data is reasonable here, and we can see that the average volume about every year, the publication of every year, is almost the same, and which means the trend of the music industry is almost steady. So we can use this assumption for some further analysis. So next we will check if there is any missing value in the release time. Okay, release time is 0, as we have delayed some. No, there is a mistake, I think. Okay, so all the records in the release country, they will have a date year attribute, and this attribute cannot be null. So all the missing problem happened is because the in the release table, some records they don't have they don't have they don't have shown in the release country table, which means there's some missing information about geographic data in the release table, and this amount is about 35,000 as shown in this query, I think. Yes, it's about 35,000. So this is not a very big amount to compare with the 0.2 billion records about all the information here. So we just detach this information at this time, and if we find any further problem, maybe we delete too much data, we will go back to extract the specific records. We want to understand how big data we mass-to analysis without any resampling methods. So we run query to find out if we set a specific time range, how many data we will have. So here we are. The beginning date is the I think there is a mistake here. There is a mistake here. But this query will be useful later. It's a good method to detect some too old singers, too old artists, because we think the people who published his own album earlier than the middle of last century almost will not get award after about 60 years. So let's just go to later part, and when we go to the artist entity, we will have more information about that. Okay, here we are. We compute how many records, how many records in recording table. Let's just go a little bit back. Okay. As for the release entity, there is also an important table called recording. The recording table describing every single song or every single record for something like a live music festival, even a speech, a lecture, or something like that. So we can think every record will belong to a release. In this situation, because this database contains only the published musics. So the recording table should contain most detailed information for every specific music. So we first go to have a general look about the recording table. So also it has a primary key ID, surrogate key GID. I just rearrange it, don't worry. The name about the record, the artist who performed this record, the length. The length is a very good attribute to filter some unreasonable records. We'll do it later. So just normal things, nothing express. So we first understand how many records do I have in this table. Okay, here we are. It's about 1.6 billion, which means it's also very big and it's not easy to handle by a laptop. And we can see the time here. The query for this summation, the SQL Server only takes about 3 seconds, and for the CPU time, for the system time, without any waiting, without any time management by the system itself, it only takes it's a very little time. So this is the most advantage we would like to choose the SQL Server to import the data and to get some basic sense about data. this is a more efficient way than just using some very slow function in Python or R. So also, we need to describe the columns in the recording table. So only the length attribute is allowed to be missing, to be null. So we just calculate how many missing here. It's a little bit long time. Okay, here we are. It's about 1.7 million. So it's about 10%. It's not many. So I think if somebody even do not have the data about the length of the specific music, we should not take care too much about that. So for generally using the length to filter some common sense, we first need to use R to get some statistical summarization for the all length data. So let's go to the RStudio server web page. So here, this RStudio server is almost the same, almost identical to the desktop version. The only difference is I need to go this site by using the IP address, because this server is only can be used in my home's network. So it don't have a public IP address, and it also do not have a web server. So we can only use this most basic method to log on that. So using R, we first need to install this package. It's called RMyCircle, and it's I think it's a good way to connect to MyCircle and just put in all the information about logging to the MyCircle server. And also there are some basic commands. I will not run that because it will take several times. And also we can use MyCircle Workbench to do the same function. One of this package, I think the most intelligent part about this package is this command. They first send this command to the SQL server and let the SQL server running to get the result. And they will save the result in a specific, there's just some alarm. Okay. They will save the data in a specific location in the memory. So I think we can rerun this command. Oops, corrupt MyCircle handle. What's the problem? Maybe I need to run this again. Okay. Okay, here we are. This, I think, just because we do not use that for a long time and the SQL server just cut down the connection. We need to just reconnect it. So here, the data variable didn't save any real data. It's only address, actually. We can have a look. Okay, it's even not an address. It's an object from MyCircle result. So when we need to extract the data from the SQL server or the memory, we can deploy this command to put our data into a data frame called data2. Okay, it may take a little bit long time. Yeah. So we can see the weakness of R here. But if you do some complex statistical analysis, it's better to use R. Like this single command will give you the most basic understanding about the distribution of this data set. Okay, here we are. This data set obviously contains many extreme values. So for the mean, it's about 200,000. So we guess that this number was calculated in the microseconds. So this number is about 4 minutes, which is a coincidence with the common sense about generally speaking the length of a song, a track, or even a record. So this kind of number and this kind of number, it might be happen especially for this number, because maybe that recording is just a long music festival and it takes about maybe a half day, maybe a whole day. But for our analysis, this kind of special event should not be considered as the candidates about a Grammy or AMA award. So we will detach this extreme value and also the extremely short value. So we can also compute the standard deviation and try to establish the reasonable range by the 3 sigma principle. But here, I think maybe we can just use the common sense, like if a record is shorter than 30 seconds, it might not be a real song. It's not be even it's not be some recording or something. So we can detach that, and that will not affect our analysis. And also for this extreme long data, it can also detach to without any influence about our data, our analysis. So actually the standard deviation is very large here because there are lots of extreme value, and it lets the mean goes away. And also we can just simply deploy a historical plot just like here. Because we use the log here, so we can still see the data is not very centralized. Maybe we can have a look about the raw data. I remember it's very ugly. Oh, it takes some time. Okay, we can see most of the data is here, and there are some extra value here, and it goes very long, but the frequency is very low. So we just use our common sense to detach the data, and actually I think we can do some summarize about that later. So we can just simply modify the circle command here. Let me do that. And once it's bigger than 3000, and 1, 2, 3. And smaller than let's say 10 minutes is 600 seconds, and put 3 zeros to be the milliseconds. So let's run that again. Okay. It's a little bit slower. Okay, let's go somewhere again. Okay, we can see the data is more centralized this time, and the variance is also smaller, and we can also have a look about histogram. Okay, it looks much smooth, and although there is a little bit of tail here, but I think it's reasonable because some songs are long, some songs are short. So we can use this data, and for the length, for this aspect, data is almost clean. This way, yeah. So we need to use circle to determine how many data we have detached, and also maybe how much we have deleted. So running this command. Okay, it's about 13 millions. So we do not delay too much. Also, the similar method to the track table. This table contains the information about a single track in an album, or actually it's just the track in a CD. So there are also lots of records here. So we use the similar methods to get rid of some extreme value. Wow, it's even larger than the recording table. So we also use the same method to find how much records we will save after this kind of filter. Okay, we still have lots of data, and if you would like to, we can check the histogram again in R. Let's copy this command and paste it here. Okay, let's do the query again. Okay. Okay, here's the problem. We can see that when R handles such a big data set, its single thread design about the program will slow down the time. I mean, have a longer waiting time. So here, the data distribution seems very smooth. Let's check the standard deviation. Okay, it's almost the same as the record. Also, we draw a plot. Okay, it's good. So for the release entity, there are actually lots of other information like release group, like language or something. As we are not very concerned about that because when people think which kind of music can be awarded in Grammy or AMA, normally people will not consider what is the release group, what kind of language they are used, so we just ignore that. So the second entity is the artist. Actually, it's also called dimension in the data warehouse, but we are just used both terminology here. So first, we also get some basic sense about the core table about this entity called artist. So the artist information is mostly about the music itself. There are not many personal information, as the name here is all the real name. So I think the official people, they just get some basic information related to the music industry. So we have two columns of name, and the name are almost the same. So we can use this column, or maybe we can use this column. It looks more organized. But both columns, they are just strings, which is not a good way to query. So maybe we can use the surrogate key or just use ID to be an index for these names. So also there have a begin date, including year, month, and day. So maybe we just focus on the year because it's really hard to say is there any relationship between the month and day to the award or not. So there are also some foreign key like area connect to the area entity, and there are also some genders here. For the gender, it's funny that some artist is null. So like this record, it's a band. So there are multiple peoples here, and some of them may female, some of them may not. So it's reasonable to be a null value here, and we will not use this column for further analysis. Also, there is a beginning area, which should be identical with the release country, the release area. But as the release area has too many missing, so we will not use this column to make sure data is correct. As all the information is open and mostly they should be correct, we just ignore these things here. Okay, let's go to the amount of the data, the volume. It's about 1 million, which is not very big for the database. So you also need to check the missing value here. Firstly, we also get some common sense about the column. We can see there are lots of columns, they are allowed to be null. As I said before, we will now take care about these two columns, so just ignore it. For the date year, we will take care about the date year column attribute, and the end date attribute, and the type. The type means what kind of artist is this person or this band is. So we need to take care about that. The area, the gender. Okay, we first go to the type. This number is the total records in the artist table. So we use this table to use this number to understand the missing ratio. So here we are. Okay, the missing ratio for type is about 75%. It's a little bit higher, so it might be not a good idea to use it to do further analysis, but we can first to look at what kind of information in the type table. So I remember I write that circle. Oh, here. Okay, we can have a look for different type, or what kind of type of artist is here. Oops. Syntax arrow. Okay, here. That's not too much. Okay, we can see that there are lots of missing, but for the specific type, there are also lots of guys here. So we can first look at the what kind of specific type they have. Okay, the type 5 and 6 should not be considered in our analysis because maybe they are just a big band with lots of people. Okay, let's go back to the begin date. And also the end date. There are lots of missing here, and some of, especially the end date, it's almost all missing. So we will not use that, and we think the year of the people first exposure to the public will not influence much. And also, because we also have the data from Twitter, so I think we can use how many Twitter they have in a specific time to measure if the people know this guy. And this factor will influence a lot about the prediction, I think. For this command, we will check how many records are in this specific time range, because we want to know if we just simply use the begin date year and the end date year to filter data, how many data we will lose. So there are lots of artists don't have any data information, so it's not a good idea to filter data by that. There's also a strange one, which is the end date is in the future. So we just extract this specific value here to check if it is a test record or something. Actually, I have searched this guy before, but let's do that again. Okay. Yeah, there is a band here. They even have their values. So this is not a wrong value. Also, we have run this command to detach some specific type of artist. Okay, the last entity is the area. The area and the place is the most important two tables in this entity. We can use this geographic information to do the visualization and summarization based on the distribution around the Earth. So we also get some basic idea about is there any missing about the address or the coordinates. So here we are. There's the name, lots of student name, and it also update time, which is only the update time about this specific record. Also, there are lots of missing on the begin date and end date area, and also have a look how many records we have. It's about 0.1 million. It's not very big. Describe it. It gives us the columns here. There's only several are allowed to be known, As we set the time, it's maybe it's missing too much, maybe not, but I think it's missing lots of information here. So we first go to the type here. Wow, it's almost no missing. So using the type, we can understand what kind of this area is. So we can have a look about the area type table. Oops. Okay, there is even a description here. So I think it's a good way to classify this geographic entity here. But more generally, there is a coordinate. We will talk it a little bit later. So here is the time. No, almost all missing. We cannot use that. Also almost missing. So we can check that the different distribution among different type of area. So we can see that most of them are others. So for the missing type, for the 6, we can put it in this category, and we can use others to visualize it or something. But it's categorized first, and also we can use the address. Woohoo! Address here. Here. Oh, okay. So actually, can we just simply use the name of an area? So I run the circle to find is there any identical name but different place. In fact, the answer is yes. There are lots of Washington County, Jefferson County here, so we cannot just directly use the name. Also, we need to understand some name in a specific category, and also is there any possibility that the address and the coordinates miss in the same time. So we run this, and we find that the different name in different category in different tables. The first one is from area table, and the second one is from the place table. So there are lots of duplicated. They are same, and for this name, for this place name, there may be lots of place in a single area. So if we want to do some detailed analysis, we can use place table. If we want to do some summarized analysis, we can use the area table. Here. Okay, we also want to know if there is any missing in both the address and the coordinates. So we compute this ratio. It's about only 6%. We consider all the records that both geographic indicator are missing. So for this 6% data I think we can just ignore it. Also, there are some very big category like country. So how big it is that this kind of data lose too much details. We just simply implement it. We just implement this circle to check what kind of country in this category. So mostly it's not very big, like Hong Kong, like some city, even like Australia. Most people are living in the East Coast. So there are also another Hong Kong, but there are some big countries like France. Singapore is also small. There are also United States. So this kind of data, maybe we need to use coordinate to do some detailed analysis. So for the generally, we also need to check the single table, the place table. So we just go through it quickly. Describe the place. Okay, just similar to the area, and also have a look about how many. Okay, there are not very much records in the place. Okay, let's check how much about the missing about the address and what kind of the missing value is. Okay, the missing value is just the empty, which is now in the string data type, but in the int or some value type, but in the text value type, text data type, they are just blank, just as our previous query. So for this data site, actually the database, there are lots of information and there are also lots of missing. So most of the problem we have been solved, and most of the interested by our interested attribute and information and data are here. So the next step, we will use this basic understanding about the database to extract some specific table. Maybe we will use a little bit smaller data set to enhance the performance. Also let us to do some complex analysis. Besides that, extracting this table and put it into a new data warehouse, we will call it ETL, but the E process here is not very hard because we have understand the data very much. And we will also use the MyCircle server to do the implementation of the data warehouse schema. So there will not be too much transform works because I think the MyCircle will understand itself in a good way. So for the loading part, as we have loaded such a complex database before, so it's also not a problem. Okay, that's all for the data description, data cleaning process about the database data.